What's going on, YouTube? It is DeVito with Davittio'sPub. Thanks for tuning in. Today we are going to discuss our solar system and the Earth in motion. Let's dive right in. Even when we feel still, Earth is spinning at about 1,000 miles an hour at the equator. Right here, the equator-ish. Give or take a couple longitudinal lines. Um, it is spinning at 1,000 miles an hour. Now we are orbiting the sun at 67,000 miles an hour, shown here, and Mercury and Venus are even quicker. This is all due to gravity, due to velocity, due to inertia, and we're going to talk about all of those. So, as we're moving around our sun, the sun is moving in the arm of the Milky Way galaxy. Everything is always in motion. And one of the things that I've seen a lot on like just social media is if we're moving so quickly, why can't we feel it? Right? I've seen that quite a bit, and people try to explain it, and some people do a good job, some don't. So it has to do with atmosphere. It actually has to do with gravity. And it has to do with, more importantly, constant velocity. Right, so we're moving at 67,000 miles an hour constantly. And I want you to think about when you're driving a car. This is the best way to try to explain this. So when you are on a long trip, I don't know if you've ever been on like a 2-day trip, so to speak, and you just kind of get in the groove of driving, especially when you're out in major cities, you're out in rural areas, and it's very just smooth, right? You're going like, just call it 80 miles an hour. You got it cruise control. You're not having to brake. You're just moving at 80 miles an hour. And you're going for 5, 6, 7 hours. You get very used to that feeling of moving at 80 miles an hour. And then all of a sudden you get behind a semi truck because the guy in the left lane's going freaking slow and you have to hit the brakes. And now you're going like 60 miles an hour and it feels like you're moving incredibly slow, right? That is constant velocity. As you get used to a speed, it becomes just a natural feeling. You just get used to it. It's the only way I can describe it, right? And that is what's happening as we are cooking around our sun at 67,000 miles an hour. In terms of the solar system, the velocity that it has, our Earth and other objects, it is orbital velocity. So as we are moving around the sun, that is defined as orbital velocity. And again, velocity is just the speed in a given direction. So for us, orbital velocity meaning a speed given in our orbit as we are going around the sun. The sun makes up 99.8% of the mass of our solar system. It is the solar system's glue. It holds everything together. Every planet, every moon, asteroid is caught in the gravitational pull. And this is a very simplified sandbox, so this is not showing everything in the Oort cloud and the Kuiper belt, but this is it's all affected by our sun. Gravity is just the force that pulls an object with mass towards it. So if you're looking at a more detailed, the Earth and the moon have gravity and they have attractions to each other. We'll talk about those attractions later. So does Mars, so does Saturn, Jupiter, Neptune, all of it. All of it has gravity with an attraction of some sort. Now, what happens if we were to remove the sun? Or we could crank, the mass down to like 50. But let's talk about removing it for a second. So if I were to take away the sun, what will happen is, number one, we're going to have two things happen. Gravity is going to change, obviously, because we just removed 99.8% of the mass of our solar system. But also inertia. Inertia is just a tendency to do nothing or remain unchanged. What that means is we have an inertia as we're moving around the planet, or around the sun, and as we take this away, the inertia is going to shift, and it is going to, the planets, as they are orbiting and they are moving, they are going to start acting where the force is no longer, right? So as we take away the force, they are going to start moving in different paths, and you're going to see them just kind of just starburst out. And that is because right now the Earth has 67,000 miles an hour of speed, and it's being pulled in because of the sun, and once it's gone, it's actually going to do this. Right? It's just going to shoot straight out because we just removed the gravity, we removed the force that it was being acted upon. So let's delete it. We no longer have 99.8% gravity in the center of our quote unquote solar system. Inertia is going to change. And there we go. Mercury is the best example. Homeboy just started flying. Mars is gone. The asteroid belt started flinging. Earth is moving very quickly. We're about to reach Jupiter. Jupiter's starting to move out of orbit. Saturn's beginning to. And there is no forces, right? So Newton explained it. There's no other forces acting. They're just going to continue doing what they are doing. And we can zoom all the way out, and you can see Mercury is moving. And it will stay that way until something else takes hold. So let's just play around for a minute. What happens? What happens if we do this? Boop. All right, now we had uber gravity, and everything's gone. So inertia, velocity, those are all in gravity are all key players with our solar system and how things move. It's an organized chaos, so to speak, right? So as we are moving, everything has a very orderly conduct based off one another. And it's cool to think about. That's what makes it part of just trying to learn and understand. So that's really all I wanted to talk about today. I just want to talk about those three things. Velocity, again, speed and the speed of something in a given direction. When we're looking on a astronomy scale, when we're looking at planetary scale, things are orbiting, so it's now defined as an orbital velocity. You have inertia, which is the property of an object to resist any change in its state of motion. And then constant velocity is why we are not feeling movement, even though we are moving incredibly fast. If you like this kind of video, like and subscribe. If you want me to improve on things, you can leave a comment down below. I am using Universe Sandbox to record all of my stuff that's regarding astronomy and planetary objects and galactic things. If you want to check them out, I'm not sponsored by them, but I love their sandbox. I love the physics engine involved. You can play around and do all sorts of crazy things, or you can just look and see how things are working naturally. Again, appreciate you guys watching. Have a good day.